Hello, we are doing today ISC Mathematics paper of class 12 paper we are doing today. Okay, so section A, it contains, okay, it contains 7, okay, it contains 15 questions. All are compulsory of 1 marks each. We will be doing that section A, question number 1. Okay, so I am starting. Okay, uh, let it open the page. I am starting it. Okay, so we will be starting, correct? So now I am starting it. It is loading the paper. It is loading. Okay, 1 second. It is loading. Okay, 1 second. I am doing it. Okay, so this paper we will be doing section A. Okay, question number 1. Okay, so this is the paper. It has opened. Now we are doing this paper. Okay, 1 second. Let it open completely. Okay, then we are doing it. 1 second. Okay, so let it open completely. Okay, so now let us start. Okay, now we are doing this question. Okay, section A. Every question is of question 1. Every question is of 1 marks. Okay, there are 15 questions. Now question number 1 of first question of question number 1. If A and B are square matrices of order 3, A is a non-singular matrix and AB is equals to 0, then the matrix B is, choices are unit matrix, B scalar matrix, C non-singular matrix, and D is the null matrix. So how we will do this sum? See here, please follow here. Here A is a non-singular matrix. That means the A is a non-singular matrix. That means the determinant of A is not equals to 0, and the product of the matrix A and B is 0, and A and B are both square matrices of order 3, correct? So we have to say what type of matrix B is. Now you please follow here. If A is the determinant of A is not equals to 0. If the determinant of A is not equals to 0, so therefore A, A inverse is possible. Inverse of A is possible. Okay. So if the determinant A is not 0, then the inverse of A is possible. Now, here is the statement number 1. Okay, now multiplying, okay, the 1, both sides by by A inverse. Okay, so what we will get here, A inverse times AB is equals to A inverse times 0 matrix. So A inverse of A is the identity matrix of the same order, order 3, times matrix B. Okay, is equal to A inverse of 0 matrix is 0. Now, the in identity matrix multiplied with any matrix, we get the same matrix back. So B is equals to 0. So B is a null matrix. So the correct choice is answer D. B is the null matrix. So answer D is the correct choice. Now we are going to the part 2. Here it is asking the question, if M and N are respectively the order and degree of the differential equation ddx of dy by dx to the power 3 is 0, then the value of m minus n is. So in the question, we are told that the order of the differential equation is m and the degree is n. Okay, degree is equals to n. We are asked to find the value of m minus n. Now you see here the equation is what? Differential equation is given in the question. ddx of dy by dx whole to the power of 3 is equals to 0. Now you differentiate it. So how we differentiate it? This power 3 will come down and we will differentiate, and the power of dy by dx will decrease by 1. So power 3 will become 2, and then you differentiate the dy by dx. Okay, so it become d squared y by dx squared. That is equals to 0. In on simplification, this is the differential equation. Now order is what? The order is the highest differential coefficient. So order is 2 because it is d squared by dx squared. So order is equals to m. Here order is m, correct? So it is d squared by dx squared. Order is 2, and the power of d squared by dx squared is 1. So its degree is 1. Degree is denoted by n. It's is 1. So the order minus the degree we have to find out m minus n. So put the values. M value is 2, n value is 1. So 2 minus 1 is 1. So the correct choice is B. So B is the correct choice. So answer is B. Okay. Now we are moving to the next part. Here it is asking the derivative of xy is equals to c squared with respect to x is, we have to, okay, do the differential. We have to here uh, do the derivative of this equation. Okay, now here we have to differentiate it. So in the question, the equation is given xy is c squared. So therefore, differentiating with respect to x on both the sides. On both sides. Okay, now you please differentiate both the sides. So on the left side, it is the product of xy. So differentiate x, it is 1. Okay, and y, you will differentiate x and multiply with y. Then you write x and differentiate y, which is dy by dx. Differentiate x, it is 1, and write it product with y. Then differentiate y and multiply it with x. Now c squared is constant. Its differential coefficient will be 0. So x dy by dx value plus y, I am moving to the left, right. It become minus y. So what is dy by dx? So dy by dx value is minus y by x. So that is dy by dx. So it is telling with the choice number C. So answer is C. Okay. Now we are moving to the next question. Here it is saying, consider there is one determinant given. It is 2a, 2b, 2c on the first row. Second row 2e, f, g. Third row 2i, j, k. Here assertion is given. The value of the determinant is 4 times this determinant a, b, c, e, f, g, I, j, k. Now reason is given. Okay, if all the elements of one row or one column of a determinant are multiplied by a scalar k, then the value of the determinant is multiplied by k. Which of the following is correct? We have to tell which of the given choices are correct. A. Both assertion and reason are true, and reason is the correct explanation for assertion. Both assertion and reason are true, but reason is not the correct explanation for assertion. C. Assertion is true and reason is false. D. Assertion is false and reason is true. So we have to check it, which is the correct choice. So let us write the determinant. Okay. Now I am solving it. See, please follow here. What is the determinant value given? Determinant is given like this. 2 first row 2a, 2b, 2c. It is 2a, 2b, and 2c. And the second row is here. Second row is 2EFG. 2E, okay, 2EF and G. Okay, and third row is here. 2IJK. 2IJ and K. 2IJ and K. Okay, now take 2 common out from the first row. Okay, so taking 2 common out. Okay, common out from from the row 1. So what we get? The determinant value will become 2 times this determinant after taking 2 common out from the first row. So it is A, B, C, and the second row will be 2E, F, G, and the third row will be 2I, J, and K. You will divide the every element of the first row by 2. Okay, so it is 2A, B, C. Other rows will be same. Now this is, now there is 2 common in the first column. uh, the second and the third element has 2 common, but the first element of the first column there is no 2 common. So this is not equals to. So the determinant value is not equal to. We cannot take 2 common out from the first column because the first element of the first column there is no 2 common. 2 common is in the second and third element of first column. So 2 is not common in the first column. So 2 cannot be taken out from the first column. So this is not equal to 4 times, it is given like that. So determinant is not equals to 4 times of A, B, C, E, F, G, and I, J, K, because 2 is not common in the first column. Okay, so this we cannot take 2 common out from the first column. So determinant A value is not equals to this. In the question, we were told the assertion is determinant is equals to 4 times of this determinant. So it is false. Assertion is false. So assertion is false. So therefore, assertion is false. So assertion is false. This is the okay the result. Okay, so this assertion is false. And what is the reason? Reason is saying if all the elements of one row or one column of a determinant are multiplied by a scalar k, then the value of the determinant is multiplied by k. It is true. Okay, we know that if any determinant, okay, if suppose a determinant is this, okay, now if a determinant is a let, now let the determinant is a b c, okay, d e f and g h I, suppose. Okay, now it is suppose this. So if I multiply every element of any row or column, then the whole determinant is multiplied by that constant. So here, okay, here, if I multiply, see here, the then this determinant will be multiplied by k. So k, the value of the determinant will be k a, k b, k c. If I multiply the first row with k, every element, k is a constant. So the whole determinant will be multiplied by k. Or if I multiply any column with the every element of any column with that same constant, then the whole determinant is multiplied with the that constant. So the reason is true. Reason is true. Okay. So the reason is true. Okay. So reason is true. Okay. Because if any row or column in the reason, here it is telling if all the elements of any row or a column of a determinant are multiplied by the same scalar k, then the value of the determinant is multiplied by k. That reason is true. So which is the correct choice? So D is the correct choice. Assertion is false, but the reason is true. So the answer is D. So here the correct choice is D. Okay, now we are moving to the next question, number 5. Here, what is the question saying? 5 numbers x1, x2, x3, x4, x5 are randomly selected from the numbers 1, 2, 3, dot, dot, dot up to 18. So the numbers are given from 1 to 18, and from these numbers we are choosing any 5 numbers, okay, x1, x2, x3, x4, x5, and are arranged in increasing order such that x1 is less than x2, is less than x3, is less than x4, is less than x5. Then what is the probability that x2 is equals to 7 and x4 is equals to 11? Now see here. Here we have to find out this. What is the probability that x1 is any number but x2 is 7? Okay, x2 is 7. Okay, now x3 is any other number bigger than 7, but x4 is given to us 11. Okay, and the and x5 is any number bigger than 11. What is the probability? So let E be the event. Let E be the event of x2 value is equals to 7 and x4 value is equals to 11. Now see here. Now the given numbers are what? Given numbers are given numbers. Now the given numbers are from 1, 2, 3, dot, 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 up to 18. These are the numbers from which we have to choose five numbers x1, x2, x3, x4, x5. Now there are five numbers to be chosen. So let S be the total sample space. Total sample space. Now, what is the meaning of total sample space? In how many ways can the five numbers can be selected from these 18 numbers? So, all possible ways. So, NS from the five numbers, if we choose from the 18 numbers, if we choose 5, it can be chosen like this 18C 5 ways. So, what is the value? It is 18 times 17 times 16 times, okay, 15 times 14, right? Five numbers in descending order, starting from 18. Okay, 18, 17, 16, 15, 14. Multiply all and divide by from 1 to 5. 1, 2, 3, 4, 5. Now you please divide the numbers on the top with the numbers at the bottom. So 5 times 3 is 15 and 15 on the top I have cut out. Now 2 times 4 is 8. Now 16 divided by 8 is 2. Now multiply these numbers. So what we get? Okay, 18 times 70. Okay, 18 times 70. So 7 times 8 is 56, carry 5, 12. And this is 8 and 1. 6, 10, carry 1, 3. Now multiply with 28. 2 times 14 is 28. 8 times 6 is 48. And 8 times 3 is 24. Here it is, okay, 12 and 6. Now add it up. Okay, this gives us 8. Okay, 8, 6, 5, and 8. 8,500. Okay, 68. 8,568. Now, in how many ways this event can be done? Okay, that x2 value is 7 and x4 value is 11. So, if the x2 value is 7, so x1 can be chosen from any numbers which are smaller than 7. There are 6 numbers. So how many ways the event E can be done? See, there are 6 LM numbers which are smaller than 7 because x2 value is 7. So x1 can be chosen from 6 numbers from 1 to 6. In how many ways? 6C1 ways times x2 is 1. Okay, so it is chosen only one way, that is 7. Now x3 will be chosen in how many ways? X3 can be chosen between the numbers 7 and 11. It should be bigger than 7 and smaller than 11. So which are the numbers? 8, 9, 10. Okay, three numbers. So from three numbers, the x3 can be chosen in how many ways? 3C1 ways. And then the number x5. X4 can be chosen only in one way, that is 14. 11. It is fixed. Now x7 can be x5 can be chosen in how many ways? From which numbers we can choose? Bigger than 11 up to 18. That is 12, 13, 14, 15, 16, 17 and 18. That is 7 from the 7 numbers. That one number is chosen in 7C ways. So in how many ways, okay, the event E can be performed? That is 6 times 3C1 is 3 times 7C1, it is 7. Now multiply all these numbers. So 3 times 7 is 21 times 6. So this is 6 and this is 12. So the event NE can be performed in 126 ways. So what is the probability of the event? PE. It is NE upon NS. Okay. So right here, NE is 126. NS is 8568. Divide with 6. So on the top we get 21 and at the bottom it is 1 carry 2 25. Okay, 4 carry is 1, 2 12 carry is 4, 48 6. Now you divide with 7. So what we get? Okay, now you divide with 3. Okay, so here it is 6. Okay, now here it is 1 carry 2 25. 25. Okay, it is okay 25. It is 6 times 4 is 24. 12. Okay, 2 carry 4 and 6 8 ja 48. Sorry, this is 8. 6 8 ja 48. Okay, now you divide with 7. So on the top we get 3. At the bottom we get 204. Now again you divide with 3 on the top and down. So at the bottom what we get? Here we get 6 carry 2 24 8. Okay, so this is 1 upon 68. That is the probability of x2 value is here. Okay, x2 value is here. Okay, 7 and x4 value 11. So this is the probability 1 upon 68, which is C. So the C is the correct choice. Okay, so the answer is C. Okay, so answer is C. Okay, now we are moving to the next question. Sixth question. Here the matrix A is given. First row is A00, second row 0A0, third row 00A. Then A to the power of n equals to. So A to the power of n value will be equal to which of the given determinants. So we have to find the value of A to the power of n. N is any number. So how we will do it? See here the matrix here matrix A is given. What is the matrix A? A is given A00. Okay, A 0 0 0 A 0. Okay, 0 A 0 and last row is 00A. Okay, 00A, which can be written like this. See here. This can be written as A to the power of 1 0 0 0 A to the power of 1 0 and 0 0 A to the power of 1. So now what is A squared? A squared value is A times A. That is A 0 0. You multiply the matrix with itself. 0 A 0 0 0 A. Okay, with it the same matrix. You multiply. So A 0 0 0 A 0 0 0 A. So how we multiply the two matrices? We multiply rows with columns. So first row you multiply with first column. Write it in the first element of first row. So multiply here. A times A is A squared. Okay. Now 0 multiplied first row with first column. 0 multiplied with 0 is 0. And again 0 multiplied with 0 is 0. That is the first element of first row. Now first row multiply with the second column. Okay, and write it first row second column. So A multiplied with 0 is 0 plus add it up all. 0 multiplied with A is 0 plus 0 multiplied with 0 is 0. Now multiply the first row with the third column and write it the third element of first row. A multiplied with 0 is 0 plus 0 multiplied with 0 is 0, 0 multiplied with A is 0. Now the multiply the second row with the first column. That will be the first element of the second row. So 0 times A is 0 plus A times 0 is 0 plus 0 times 0 is 0. Now second row, first column. Oh, sorry, second column. So 0 times 0 is 0. 8 times A is A squared. And 8 times 0 times 0 is 0. Now second row, third column. 0 times 0 is 0 plus 8 times 0 is 0 plus 0 times A is 0. Now multiply the third row of the first matrix with the first row of the second matrix. 0 times A is 0 plus 0 times 0 is 0 plus 0 times 0 is 0. Okay, now the third row, second column. 0 times 0 is 0 plus 0 times A is 0 plus 8 times 0 is 0. Now third row, third column. 0 times 0 is 0 plus 0 times 0 is 0 plus 8 times A is A squared. Now simplify it. So what we get? Here we get A squared, 0, 0, okay, again 0, A squared and 0, and here it is 0, 0, A squared. Okay, now A cube. Now find out the value of A cube. So A cube is what? A cube is equal to A squared times A. So this is the A squared, right? This matrix. It is A squared 0, 0. This is 0, A squared 0, 0, 0, A squared. Now multiply it with A. Now what is A? A is the given matrix. That is A 0, 0. It is A 0, 0, 0, A 0, 0, 0, A. Now multiply it. So multiply by the same method. That is rows into columns. So first row multiplied with first column. Right? The first element of first row. So A squared times A is A cube. Now 0, okay, multiplied with 0 is 0. 0 multiplied with 0 is 0. Okay, multiply the first row with the second column. Okay, A squared times 0 is 0. Okay, 0 times A is 0 and 0 times 0 is 0. Okay, add it up. Now multiply the first row with the third column. Write it first row, third element. Okay, now this is A squared times 0 is 0 plus, okay, 0 times 0 is 0 plus 0 times A is 0. Now multiply the second row with the first column. 0 times A is 0 plus A squared times 0 is 0 plus, okay, 0 times 0 is 0. Now multiply the second row with the second column. 0 times 0 is 0. A squared times A is A cube plus it is A cube. Okay. Now 0 times 0 is 0. Now multiply the second row of the first matrix with the third column of the second matrix. So it is 0 times 0 is 0 plus A squared times 0 is 0 plus a 0 times A is 0. Okay. Now multiply the third row of the first matrix with the first column. Okay. So it is 8 times 0 times A is 0 plus 0 times 0 is 0 plus 0, 8 squared times 0 is 0. Now the third row multiplied with the second column. So 0 times 0 is 0 plus 0 times A is 0 plus A squared times 0 is 0. Now third row, third column. So 0 times 0 is 0 plus 0 times 0 is 0 plus A squared times A is A cube. Now what is A cube? Simplify it. So this is equals to A cube. Okay, 0, 0. 0. Okay, this is a cube and this is 0. So this is 0, 0 a cube. So what we are noticing? So when it is here, okay, a to the power of 1, a can be written as a to the power of 1. So here the powers of a in the matrix are all 1, all other elements are 0 when it is a squared. So the powers of a along the diagonal, main diagonal, are power 2 2 2. All other elements are 0. And when it is a cube, the elements along the, okay, leading diagonal are a cube, a cube, a cube. All other elements are 0. So following in this way, the a to the power of n will be what? So it will be the elements in the leading diagonal will be a to the power of n. Okay, a to the power of n. The leading diagonal elements will be a to the power of n, and all other elements will be 0. Okay, so that is the conclusion. So a to the power of n will be this. The elements along the leading diagonal will be a to the power of n, and all other elements will be 0 of the matrix. So which is the, it is telling. So it is telling with the a. Okay, because in a the elements along the leading diagonal are a to the power of n. All other elements are 0. So the answer is A. So that is the correct choice. Okay. Now we are moving to the next question, number 7. Now here, observe the following graphs. There are 4 graphs given in the question. Okay. Now there are questions on this graph, 4 graphs. Here it is saying that observe the following graphs A, B, C, and D, each representing different types of function. So these are the graphs of different types of functions. Okay, now these are the 4 graphs you may see. So these are the 4 graphs given in the question. Okay, now the statement. Here the question is statement number 1. A function which is continuous at a point may not be differentiable at that point. That is the statement number 1. Statement number 2. Graph C is an example. This is the graph C. This is the graph C. The second part of the question is related to the graph C. So it is saying that graph C is an example of a function that is continuous, but it is continuous, but not differentiable at the origin. Now, which of the following is correct? There are 4 choices given in the question. A. Statement 1 is true and statement 2 is false. B. Statement 2 is true and statement 1 is false. C. Both the statements are true. D. Both the statements are false. Now we have to, okay, think and say which is the correct choice. Okay. Now statement number 1. A function. What do the statement number 1 say? A function which is continuous at a point may not be differentiable at that point. This is true because we know that a function, if it is continuous at a point, may not be differentiable at that point. Like, for example, here is the one type of graph, here is the one type of function. Okay, now solution. Here is the one type of function. Okay, fx is equals to let fx is equals to mode of x. Okay, so this function is continuous at the x equals to 0. This function, the graph is like this. Okay, of this function fx is equals to mode of x. So this function is continuous at x equals to 0 at origin. Okay, but at the origin the function is not differentiable because there is a sharp turning here at origin. So the function is continuous. So this is continuous. is continuous, is continuous, okay, at origin at x equals to 0, but but not differentiable, but not differentiable, but not differentiable at x equals to 0. So a function can be continuous at a point, but may not be differentiable at that point. It is true. So that is what the statement 1 is saying. A function which is continuous at a point may not be differentiable at that point. It is true. Okay, now the statement number 2. Graph C is an example of a function that is continuous but not differentiable at the origin. That is false. Now you please follow here. Now what is the graph? What is the continuous? Now you see here. Here C is, this is the point at the origin, okay, of the graph. Here the function is continuous. Okay, graph has no cut at or no breaking, so it is continuous. That part is true. Okay, graph, it is saying the graph C is an example that is continuous, so it is continuous. It is true, but not differentiable at the origin. It is false. So for the not differentiability, now what is the condition? The condition is that the for not differentiability, for not differentiability. Now, for not differentiability at a point, at a point. Okay, what are the conditions? The conditions are the graph. Okay, the graph should have a sharp turning. The graph has a sharp turning at that point, at the point, at the point. Okay, now like this, sharp turning like this, see, like this. It is a sharp turning. Okay, now, okay, but the graph, see, there's no sharp turning. There's no sharp turning like that. So this is the first condition for non-differentiability. Okay, for non-differentiability. Now second is, okay, a unique, a unique, a unique tangent can't be drawn. A unique tangent cannot be drawn, cannot be drawn at the point, cannot be drawn at that point. Okay, now here in this case, in the given case, a tangent can be drawn, a unique tangent can be drawn to the graph. Okay, so a unique tangent like this can be drawn to the graph. So here is not satisfying that condition. For a unique tangent cannot be drawn for a at the point where there is a turning point. Okay, there cannot be drawn. Here it can be drawn. So that condition is not satisfying. And third condition is that for non-differentiability, okay, there should be a breakage. The graph should not be continuous. The graph, okay, at the point, at the point is non-continuous, is not continuous. Not continuous. That means there is a hole or break. The graph at the point is not continuous. Okay. Now in the present case, the graph is continuous. It is not a hole or not breakage at x equals to 0. Okay. And the last condition for not differentiability is that the graph is perpendicular to the x-axis vertically along the y. It is running vertically along, means vertical to the x-axis at the point. The graph, okay, the graph becomes vertical. Okay, become vertical. Okay, vertical at that point, at the point, at the point where it is non differentiable. Here the graph is not okay vertical. Okay, it is curved. So it is false. So it is saying that it is not differentiable at the origin. It is differentiable. Okay. So statement B is false. Statement A is true. Okay, because a function may be continuous at a point but may not be differentiable. That is true. But in the given case, the example, the graph C is continuous at origin, that is correct. But it is not differentiable, it is false. It is differentiable. So which is the correct choice? Okay, here statement 2 is statement 1 is true. Okay, but statement 2 is false. That is the correct answer. So the correct choice is E. So answer is E. Okay. Now we are moving to the next question. Number 8. Here fx is equals to, this is the fx value, kx squared plus 7x minus 4. And f dash pipe value is, that means the f dash value, that is the differential coefficient of fx at x value pi is given, its value is given 97. Then what is the value of k? We are asked. The choices are A is minus 4, B is 0, C is 4, D is 9. From these choices, we have to choose a one correct choice. Now see here. Here the fx value, the function is given like this. Please follow it. It is kx squared plus 7x minus 4. So what is f dash x? So differentiate it. So therefore f dash x is differentiated. The power of x will come down to k. It will be multiplied with k, and the power of x will decrease by 1. So it will become x. Now 7x you differentiate, it will be 7. And 4 is a constant, its differential coefficient is 0. Now put the value of x pi, because f dash pi value is given. So in the place of x you put pi. So f dash pi, okay, is equal to, here in the place of x you write pi. So this is 7k times pi plus 7. Value is given to us in the question, 97. So we have to find the value of k. Now simplify it. Okay, 7 times pi is, oh sorry, it is 2. Sorry, I have written 7. Sorry, by mistake. It is 2. 2 times pi is 10. 10k plus 7. Plus 7, I am moving to the right side. It is 97 minus 7, which is 90. 97 minus 7 is 90. So 10k value is 90. So what is the value of k? So the k value, 10 from the left you take to the right. So 90 divided by 10, k value is 9. Now the correct choice is number D. So answer is D. So the k value is 9. Now we are moving to the next question, number 11. So what is the question? Statement number 1. If a relation R or a set A satisfies R is equals to R inverse, then R is symmetric. Statement number 2. For a relation R to be symmetric, it is necessary that R is equals to R inverse. Which one of the following is correct? Statement 1 is true and statement 2 is false. B. Statement 2 is true and statement 1 is false. C. Both the statements are true. D. Both the statements are false. Now we have to, okay, check with which is true, which is false. Okay, number 1. Now I am checking statement number 1. If a relation R on a set satisfies R equals to R inverse. Now in the question we are told to us that R is equals to R inverse. then R is symmetric. Then R is symmetric. Now, what is the meaning of symmetric? Now, see, a symmetric relation is like this. Okay, R is symmetric. R is symmetric relation. If if it follows this condition, if AB is an element of R, then it implies that BA is also, we change the order. Okay, first it is AB. Now change the order. B comes in the first place, A goes to the second place. BA has to be an element of R. So that is, we call the relation R is symmetric. Now, here in the R inverse means what? R inverse means that if R, okay, if a element is like this, see, if AB is a element of R, then R inverse, then BA, BA is a element of R inverse. That means change the order. So in the question we are told that R is equals to R inverse. So R is equals to R inverse. So if R is equals to R inverse, that means if if AB is a element of R, okay, therefore BA, okay, is a element of R inverse. Okay, and both are, the relation R is equals to R inverse. Okay, so therefore if R is equals to R inverse, okay, so the BA will be also a element of R. So therefore BA is also a element of R. Okay, because it is equal. So R is symmetric. So because AB is the element of R, then because by R inverse we know that BA will be the element of R inverse. So now because R is equals to R inverse, so BA is the element of R. So therefore R is symmetric. So the relation R is symmetric. Okay, so R is symmetric. So it is symmetric. So the statement A1 is true. So statement, therefore, the statement 1 is true. Correct? Okay. Now that is statement number 1 is true. Now let us check statement number 2. For a relation R to be symmetric, it is necessary that R is equals to R inverse. That is true. Now we know that, okay, we know that if, okay, if, okay, R is symmetric, if R is symmetric, okay, R is symmetric, then therefore R has to be a subset or equal set to R inverse, and R inverse has to be a subset or equal set of R. So following, therefore because R is a subset or equal set of R inverse, and R inverse is a subset and equal set of R, so following these two, so therefore R has to be equal to R inverse. So it is true. So if a relation R is symmetric, it is necessary that R should be equal to R inverse. So statement number 2 is also correct. So statement 2 is also true. So statement 2 is true. Okay, so both are true. So statement 1 is true and statement 2 is also true. So the correct choice is C. C. Both the statements are true. Okay. So the correct choice is C. So the answer is C. Okay, now we are moving to the next question. Okay, now we are going to the next question, number 10. The equality tan of cot inverse x is equal to cot of tan inverse x is true for all x element of R. Reason, the identity tan inverse x plus cot inverse x value is pi by 2 is true for all x element of R. Which of the following is correct? Now we have to check which of the following is correct. Okay, now you please follow here. Let us check as assertion first. Okay, it is telling it is true for all values of x. Okay, now see tan inverse here, the tan of cot inverse, what we are given in the question, tan of cot inverse x. So tan inverse of cot inverse x. Now cot inverse x can be written as, we know that cot inverse x, we know that cot inverse x is equals to tan inverse 1 upon x. Okay, so in place of cot inverse x, I am writing it as tan inverse 1 upon x. So tan inverse 1 upon x value is 1 upon x. That is LHS. Okay. Now RHS. RHS is given what? RHS is given to us cot of tan inverse x. Okay. Now cot of tan inverse x. So tan inverse x we know. Tan inverse x is equal to cot inverse 1 upon x. Okay. So in place of tan inverse x, we can write it as, okay, cot inverse 1 upon x. Okay. So cot inverse 1 upon x value is 1 upon x. Okay. This is true. So therefore 1 upon x is equals to 1 upon x. So LHS is equals to RHS. But it is not true for every value of x. If x is 0, then it is not true. Okay? Because then it is undefined. It is true. The equality is true. The equality is true. Okay? For all for all x element of real number, except 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 at x equals to 0. So in the question, we were we are told that this equality is true for all values of x. It is not true for all values of x. It is true for all values of r. Okay, here it is saying that all x element of real number. It is true for all real numbers except 0. So it is not true for all real numbers. So this statement is false. Assertion is false. The identity, now reason, the identity of tan inverse x plus cot inverse x value is pi by 2. That is true. We know that. We know that this identity is correct. Okay. Tan inverse x plus cot inverse x value is always pi by 2. That is true. Okay, for all x element of real numbers. For all x element of real number. Okay, for all x element of real number. Okay, for all x element of real number. This is true. So the reason is true, but assertion is false. Reason is true. So what? Which one will be the correct choice? So the correct choice is D. Assertion is false, but the reason is true. Okay. So the answer is here D. So the correct choice is here D. Now we are moving to the next question. Okay. Now number 11. What is told in the question? Given two events, there are two events given, A and B, such that probability, this is the condition probability. Probability of A with the condition that B has already occurred. It is written as A oblique B. Value is 0.25. And the probability of A inverse B, or A intersection B, the probability of A intersection B, that means together happening, is 0.12. Then you have to find the value of A dash, probability of A dash A, okay, complement intersection B. Okay, what are the values? A is 0.36, B is 0.48, C is 0.88, D is 0.036. Which one is the correct choice? We have to find out. Okay, now let us start the sum. So I am doing it. Now this is the condition probability. So probability of A oblique B. This is the probability of happening of A with the condition that B has already occurred. So this is equals to, formula is P A intersection B upon P probability of B. This formula P A oblique B is formula is probability of A intersection B upon probability of B. Okay, now put the values. Probability of A intersection B value is given in the question. It is 0.25. Okay, now probability of A intersection B value is given in the question. It is 0.12 upon probability of B. We don't know what is the probability of B. So the probability of B will be how much then? The probability of B will be equals to, okay, 0.12 whole upon 0.25. Okay, so this you move the decimal point two places to the right in the numerator and denominator. That gives us 12 upon 25. Now multiply both the numbers on the top and down with 4. So it is 12 times 4 upon 25 times 4. Okay, if we multiply both the numbers on the top and down with the same number, fraction value will remain same. So it is 48 by 100. That is the probability of B. Okay, which is equals to 0.48. Okay, now what is, we have to find the probability of A dash inverse B. Now, what is the meaning of probability of A dash B? Now, I am explaining you with the help of a diagram. Now, this is the two sets A and B. They are intersecting like this. This is A, this is B. Now, A dash intersection with B. A dash means what? Leaving the A, okay, and all else. Leaving A and all else and intersecting with B. So leaving A and intersecting with B is this part, which is only in B, which is only in B. So only in B, how we can write? So this part, P probability of A dash intersection B. This is only B. This is the probability of B minus the probability of A intersection B. So from the whole B, if we subtract A intersection B, we will get what is here shaded. That is A dash intersection B, only B. Now put the values. We have found out A intersection B, probability of B is 0.48 and minus probability of A intersection B, which is 0.12 given in the question. So right here 0.12, subtract that. So this comes to 0.36. So that is the probability of A dash intersection B. So which is the correct choice? Here the correct choice is A, 0.36. So the answer is here A. Okay. Now we are moving to the next question. Number 12. Here it is saying the value of the determinant of matrix A of order 3 is 3. If the C is the matrix of cofactors of the matrix A, then what is the value of the determinant of C squared? Okay, so in the question, what are we told? We are told like this, that there is a one matrix denoted by A. Its value is given determinant A. Determinant A, the determinant of matrix A. A is of order 3. So A is determinant A value is given in the question 3. And A is a matrix. A is a matrix. In the question we are told A is a matrix of order 3. That A is a matrix of order 3. That means it is a square matrix. 3 times 3. Okay. So 3 times 3. And we are told if C is the cofactor and C is the matrix of cofactors, okay, that means adjugate. So C is the adjoint of A. Okay, so C is the adjoint of A. Adjoint of A. So the matrix, so the determinant of C. Now, if C is the adjoint of A, so the determinant of C is found out like this. Okay, so it is not the adjoint of A, it is actually the transpose of adjoint of A. So whether it is the transpose or whether it is, we know that what we know that the matrix, that the determinant of A is same as the determinant of A transpose. So determinant cofactor, the adjoint of A is what? Adjoint of A is the matrix which is, okay, cofactor, the transpose of the cofactor. Transpose of the cofactor. That is the adjoint of A. But whether it is the adjoint A or its transpose, the determinant value will be same. So the determinant of the C will be like this. C formula is, it is determinant A. That is the determinant of adjoint of A. We know this. That determinant of adjoint of A value is equal to the determinant A to the power of n minus 2, where n is what? N is equals to order of the matrix A. Order of matrix A. Okay. Order of matrix A. So whether it is the matrix A or transpose of matrix A, determinant value will be always same. So whether we find the determinant of adjoint A or its transpose, value will be same. Okay, so that is the determinant A to the power of n minus 1. N is the order of matrix A. So matrix, okay, determinant of matrix A is given in the question 3. Okay, so it is 3. Write the value of determinant A to the power of n minus 1. N is the order. So order is 3 minus 1. So that is 3 to the power of 2. So the determinant of the cofactor of determinant, that is the determinant of C, value will be here what? 9. 3 squared value is 9. So what will be the value of the c squared, determinant of c squared. So that will be same as determinant of c whole squared. So determinant of c value is 9. So it will be 9 whole squared, which is 81. So determinant of c squared will be 81. So which is the correct choice? We have to tell the answer only. So its value is 81. So that is the answer. So determinant of c squared value is 81. Now we are moving to the question number 13. Here in the question we are told, if a relation R on the set ABC, this is a set A, its elements are ABC, defined by there is a one relation R. It's there is a single element of R. It is BB. Okay, there is a single element BB. Then classify the relation. We have to tell what type of relation this R is. Okay, now this relation R is not transitive. Oh, sorry, it is not reflexive. A is not reflexive. Why? Because reflexive is what? Now let the set, we are denoting this set. Let set A is equals to this set ABC. Okay. Now a relation on set A is reflexive. A relation, okay, a relation R on set A is reflexive when we call the relation A is R is reflexive if R contains this element, if R is equals to, okay, A should be, okay, related to A, BB, there should be BB as well, and CC, okay, CC. But in this relation R, there is only BB. There is not AA, not BB. So the R is not. So R is not reflexive. Not reflexive. Okay, because there are, okay, not reflexive. There are, these elements are missing, A, B, and CC. So it is not reflexive. It is transitive. Now, transitive is what? A relation R is transitive. Okay, R is transitive. R is transitive when? If the R is transitive, if AB is an element of R, if A is suppose an element of R, therefore BA, that means the ordered, that is the element of the ordered pair, okay, reverse order, should also be the element of R. Okay, now in this case, here in this case, the relation R, there is a single element. Okay, now there is a single element, BB. BB is an element of R because there is a single element, BB is an element of R. So if I change the order of the element, if I write the second element first and the first element second, so I am changing, okay, the order. So second element I am writing first and the first element I am writing second place. Still we are getting the same ordered pair BB. It is also an element of R. So it is transitive. So therefore R is transitive. So it is transitive. Okay. Now next it is anti-symmetric. Okay, oh sorry, not transitive, sorry. It is called symmetric. Oh my god, I have told mistake. Okay, it is called symmetric, sorry. Oh my god, what I have said. Okay, it is called symmetric. Correct? So it is called symmetric if, okay, if are you understanding? It is called the symmetric, okay, okay. So we are here. Okay, doing. Okay, 1 second. So here it is. Okay, I am writing here. Okay, now my page is not working. Okay, now please you watch. Oh my god. Okay, now it is not working. My page is not working. Okay, now let us. Oh my god. Okay, now let us rejoin again. Let us rejoin again. Okay, so I am rejoining again. Okay, so it is. Okay, now it is not working. Okay, now let us rejoin again. Okay, now you please follow here. I am rejoining again. 1 second. Okay, because my writing page is not working. Okay, now let us rejoin. Okay, now let us rejoin. Okay, 1 second. Okay, so it is. Okay, now 1 second. I am rejoining it. Okay, so it is rejoining. Okay, I have rejoined. Okay, so let us continue. Okay, now I am continuing. 1 second. Let the page open. Okay, it is was not working. Okay, let it open. Then we are continuing. Okay, now 1 second. It is opening. Okay, now here it has opened. Okay, now 1 second. So it was not working. 1 second. Okay, now 1 second. 1 second. It let it open nicely. Okay, okay. So let it open nicely. Then we will be able to work out. Okay, now right. Let us end up the let us end the class now up to this only. I will be doing the remaining questions other day because it is not working. Okay, now okay. Have a very fine day. I hope